Assalamu alaikum everyone. So in the last class I have explained the Rolle's theorem and the example based on the Rolle's theorem. So in today's class I will explain the mean value theorem. Mean value theorem is the extension of the Rolle's theorem. Now write mean value theorem. Mean value theorem is the extension of the Rolle's theorem. So write down first statement of the mean value theorem. Statement. F is a f is a function from closed interval a comma b into set of real number r. F is a function which is between a closed interval ab into r, which is r is the set of real number, is continuous in closed interval ab and differentiable in open interval ab. This function is continuous in the closed interval ab and differentiable in the open interval ab. Then there is a point, then there is some point, there exists a point C in interval AB such that f dash of C is equal to f of B minus f of A whole divided by B minus A. So this is the statement of the mean value theorem. We are considering here one function which is f from closed interval AB into R, and it is continuous in closed interval AB and differentiable in the open interval AB. Then if this is satisfied, then there exists a point C in AB, open interval AB, then there exists point C in AB such that f dash of C is equal to f of P minus f of A divided by P minus A. So this is the statement of the Rolle's theorem. Now first we have to understand what is closed interval and what is the open interval. In closed interval, it is represented by a comma b in the square bracket closed interval. In closed interval, these 2 points including, we have to consider the 2 points a comma b, or suppose we are having 0 comma 1 closed interval. So we have to take the point 0 also and the number which is greater than 0 and less than 1. So we have to consider both 0, 1 and the number lies in between 0 and 1. Okay. In open interval. In open interval. Open interval is represented by like this, and we have to consider in the open interval only the point lies between A and B. Just the point which is lies between AB, we can't include, we can't take the point AB. Just we have to take the point in between A. So this is open interval. In closed interval, we have to take the point in between AB, also the point A and B. So this is the difference between closed interval and open interval. Now we can derive this theorem, we can understand this theorem by using the graph of y is equal to, write down point y, the derivation of this theorem or the how to understand, write down point. First consider a graph let y is equal to f of x. Consider the graph of this theorem, graph of this y is equal to f of x. So draw figure here. So this is the statement of the Rolle's theorem. Now for understanding, draw one figure here. So this is the point O, origin. This is x-axis, y-axis, x dash axis, y dash axis. So now we are taking the graph of y is equal to f of x, which is nothing but the parabolic form. Draw like this. Okay. So like this you have to draw. So this is the point A here. This is the point A here, and this is point B. Point A and B. So here it is drawn a tangent to this curve. Draw a tangent to this curve like this. I am taking one tangent to this curve. Then we will get, which is, we have to draw another line, and this line is perpendicular to x-axis OX, and draw one tangent by using this red pen. I have drawn one tangent which is touches this curve. So this is C comma f of C. So it is A comma f of A. This point is A comma f of A. This point is B comma f of B. So this is the point where the curve touches the tangent. So it is C comma f of C, and this one is the point C. So now again draw another line, which is like this. You have to, we joined these two. Okay. So this is the point C. Point A and B, then there exists a point C, and this is the line which touches the curve, parabolic curve. So this is known as a tangent to the curve. And these two lines, another line we have drawn, which intersect this parabola at a comma f of a and b comma f of b. This line just touches the parabola, so it is known as tangent to the curve. And these lines which intersect or which cut the parabola at two different points, so this line is known as secant. This one is secant, and this one is tangent to the curve, given curve. And these lines secant which intersect, means which cut the given parabola at 2 points. So this one is known as secant. Okay. So to understand the mean value theorem, we are taking a drawing. We have to we can understand by using geometrical figure. So by using the graph of y is equal to f of x, this graph is nothing but the parabola. Okay. Now by let y is equal to f of x. Okay. By using, we know that f dash of c, right, second point, f dash of c is the tangent to the curve. f dash of c. By the mean value theorem, f dash of c is tangent to the given curve. Okay, is the slope of the tangent. Sorry, is the slope of the tangent to the given curve. Is the slope of the tangent to the curve. Now third point. So f dash of c is here. This is called f dash of c. This is the slope of the tangent. Y is f of x, and now write third point. By the mean value theorem, we know that f dash of c is nothing but we have by the mean value theorem, write by mean value theorem, f of b minus f of a divided by b minus a. By the mean value theorem, f of b minus f of a whole divided by b minus a is the secant drawn between, is the slope of the secant drawn between, we have secant in between a comma f of a and b comma f of b. Close this bracket. A comma f of a and b comma f of b. So this f of b minus f of a whole divided by b minus a is the slope of secant drawn between these two. Okay, now write fourth point. Again, by mean value theorem, there is a point C. There exists a point C in AB. There exists a point C in AB such that the slope of tangent at the slope of tangent at C comma f of c, the slope of tangent is parallel to the two secant. This slope is parallel to, we can see that this line at C is parallel to both a comma f of a, this line and this line is parallel to the secant drawn between a comma f of a and b comma f of b. So in 4 points we can understand by using the graph. So first I will explain once again the statement. F is a function in between closed interval a b into r, and it is continuous in closed interval and differentiable in the open interval. If this satisfied, then there exists a point C in a b, or we can write there exists some point C in a b such that f dash of c is equal to f of b minus f of a whole divided by b minus a. This is the statement of the mean value theorem. So for understanding, we have to take the graph of let y is equal to f of x. The graph of y is equal to f of x is the parabolic form. Okay, now we have drawn f dash is the slope of the tangent to the curve. F dash is here. We got f dash here. So this one is the tangent to the curve. Tangent is the line which touches the parabola. So this is the curve of the parabola. So this line is tangent. So by the mean value theorem, f of b minus f of a whole divided by b minus a is the slope of the secant drawn between a comma f of a and b comma f of b. So one line touches the curve, it is known as tangent. Another line is drawn which cut the parabola at two different points. So this is known as secant. So this is the slope of the secant drawn between a comma f of a and b comma f of b. So then there exists a point C in AB such that the slope of the tangent is parallel to both the secant drawn in between A comma f of A and B comma f of B. We can see that these lines, the middle line, the line at C, which is the middle of both, it is parallel to both the secant drawn in between A comma f of A and B comma f of B. So it is the so geometrically we can prove that by using the parabola. So now take one example based on the mean value theorem. Now write down example. So mean value theorem is an extension of the Rolle's theorem. In Rolle's theorem we have find only f dash of c. In the mean value theorem f dash of c is equal to f of b minus f of a whole divided by b minus a. So write down one example. Verify mean value theorem. Write down example. Write one example. Verify mean value theorem. For the function f of x is equal to x square in the interval 2 comma 4. A function is given to you and the interval is given to you 2 comma 4. So we have to verify the mean value theorem for this function. So write down solution. So this function is the given function f of x equal to x square is continuous on the closed interval in closed interval 2 comma 4 and differentiable in open interval 2 comma 4. The given function is continuous in 2 comma 4, the closed interval 2 comma 4 and the open interval 2 comma 4. So how it is continuous and differentiable? So because the function f dash of x, f of x is x square. So find the differentiate this, then we will get f dash of x is equal to 2x. Okay. Now substitute the value of 2 and 4 in this, then we will get, let first x equal to 2, then we will get f dash of x as 2 into 2. 2 to the 4. Okay. Now here let x equal to, now again let x equal to Second point, this one is A and this one is B. First point we have taken 2 and now take second point 4. Then we will get f dash of x as replacing this 8. So we got f dash of x by putting the value of A and for B, the given interval 2, 4. So we got values 4 and 2. That's why the given function is continuous in the interval 2, close interval 2, 4 and differentiable in open interval 2, 4. Now by the mean value theorem, there is a point by the mean value theorem, just write we have f dash of c as f of b minus f of a divided by b minus a. Okay, now first find f of a and b. F of x is given to you as f of x is x square name these as equation 1, this one is equation 2, this one is equation 3. Okay, by using equation 1, right here 1, f of x is equal to x square. Now substitute, find f of b. What is b here? B is 4. B is point 2 comma a is, this point 2 comma a is a comma b. So b is here 4. Substituting the value of 4 here. Let x equal to 4. F of 4 equal to 4 square. 4 4s are 16. Okay. Now let x as a 2. So f of 2 is 2 square is 2 to the 4. So this one is f of b, and this point is f of a. F of a and f of b. Substituting this value in this formula, you will get f dash of c equal to f of b we got. Now write this one. This is equation 3 and this one is equation 4 and this one is equation 5. So by using equation 4 and 5, right? By using equation 4 and 5, we get, by using equation 4 and 5, we get, by substituting f of b and f of a value in this formula, we will get f dash of c equal to f of b is 16 minus f of a is 4 whole divided by b minus a. B is 4, a is 2. Then 16 minus 4 is 12 divided by 4 minus 2 is 2. So this one is 2 1s are 2, 2 6 are 12. So f dash of c we got finally as f dash of c is 6. So we got by using f dash of c by using this formula. Now by according to the mean value theorem, there exists a point by the mean value theorem, I am writing here short form mean value theorem. There is some point, there exists point C in AB, C in A comma B, or we have AB as 2 comma 4. There exists point C in 2 comma 4. Interval which is given to you as 2 comma 4. So write simply what is given to you, 2 comma 4, such that Then we got f dash of c as 6, but we have f dash of x is equal to 2x. Okay, and f dash of c is, here we are replacing x by c, then we have this one, we got this as 6. So what is x here? We can see we have to take one number, we have to choose one number. By the multiplication of that number, this f dash of x will become 6. So we have to choose, means we have to take the number by the multiplying that number by 2, then we will get 6, answer 6. Then now let x as 3, then we get f dash of c as 2 into f dash of x is 2 into 3 is equal to c, 6. That means this implies c is equal to 3. So 2 3s are 6. We got a dash of 6 c as 6 by using this formula. So we have, but we had the differentiation of the given function is 2x. That's why we have to take, we are taking number 3, which is by multiplication of 2 into 3, then we got 6, answer 6, the value of the f dash of c. That this means there exists a point c in 2, 4. So we can see the number 3 lies in between 2 and 4. That is the verification of the given mean value function. This is the verification of the, hence we proved that the function satisfies mean value theorem because there exists point c. We also proved that f this also a dash of c we got by using this formula. So with this I will stop. I will continue in the next class. Okay, thank you everyone. Bye.